Welcome to Dreaming Scientist's Sleepy Stories, a place where the mysteries of the universe guide you toward peaceful sleep. Something quiet and unusual surrounds you tonight, a presence so gentle you never feel it, yet so vast it shapes the very space you move through. Imagine an almost weightless scar in the galaxy, a warm, invisible hollow filled with faint, ancient light. Scientists call it the local hot bubble, a soft glow left behind by stars that lived their brilliant lives and then dissolved into the night. Inside this enormous cradle of million-degree plasma, your solar system drifts like a small ember, floating through the remnants of cosmic fire. Tonight, you follow the fading memory of those long-gone stars, to see how their endings helped create your beginning, and how the dust from their final breaths still lingers in the air you inhale. And if this calm journey brings you a moment of ease, know that I'm grateful you're here. A gentle like or quiet tap on subscribe is never just support. It is a small signal carried across the dark, helping these night stories continue. So, breathe softly, let the day loosen its grip, and drift with me into the question that started it all. Part 1. Are you living inside the ghost of a supernova? Just beyond the border of your solar system lies a vast emptiness, a hollow sphere stretching nearly 1,000 light years across. It is filled with extremely thin gas, warmed to more than 1,000,000 degrees, and shaped by the echoes of at least 15 stellar explosions over the past 14 million years. According to recent NASA research, this immense cavity may be the quiet shell left by those ancient blasts. Your solar system now floats near its center, wrapped in the soft afterglow of stars that died long before humanity existed. It sounds like a story from distant imagination, yet the evidence is clear. Using delicate X-ray measurements from the DXL mission and precise distances from the Gaia telescope, astronomers have mapped this structure in 3 dimensions. They found a basin of hot gas surrounded by delicate walls of interstellar dust, the frozen ripples of old explosions still expanding through the thin medium that holds your sun in its arms. In 2022, researchers at the Center for Astrophysics, Harvard, and Smithsonian published a detailed map tracing this bubble with remarkable clarity. They discovered something beautiful. Nearly every nearby young star cluster, Taurus, Perseus, even Ophiuchus, sits right along the bubble's boundary. These stars were not born in quiet clouds, but in the compressed edges sculpted by shock. Waves from dying suns, destruction in its cosmic patience, became creation. The same violent brilliance that once tore space apart eventually shaped the clouds that formed Earth. And you, and everything you've ever known, as one astrophysicist described. Every star-forming region within hundreds of light years seems to be connected to this single, ancient structure, as though you are living inside a lingering afterglow. Your sun didn't begin its life here. It drifted into the bubble roughly 5 million years ago during its gentle orbit around the galaxy. Now, near the center, the space around you is far more empty than average, almost 100 times thinner. Here, a lone atom may wander across a room-sized space before meeting another. Yet even this delicate emptiness carries a faint shimmer of soft X-rays, a whisper from the fires that once filled this place with unimaginable heat. Scientists first suspected this bubble existed in the 1970s, when they noticed a mysterious glow of soft X-rays across the entire sky. It wasn't solar wind. It wasn't distant galaxies. It seemed to come from every direction, as though the solar system was floating in a vast cloud of hot gas. And they were right. In 2020, the eROSITA telescope aboard the Spectra G mission scanned the sky and revealed something even more intricate. A network of connected cavities stretching outward, linking your local bubble to others nearby, like the Lupus superbubble and the Gum Nebula. The region around the Sun is not a calm, uniform sheet of space. It is a quilt of hollows carved by dying stars, each one an imprint of their final breath. When a star explodes, it releases more energy in a moment than the Sun will emit in its entire lifetime. This shock sweeps up gas, heats it, and pushes outward, shaping its surroundings into dense shells where new stars can form. After millions of years and many overlapping blasts, a single enormous cavity emerges edged with glowing filaments. The local hot bubble is one of the clearest examples of this process near Earth. And somehow, your solar system rests almost exactly at its heart. A location so improbable it feels like choreography, not chance. A natural dance of stars unfolding. Over millions of years, even Earth has kept a record of these events. In ocean sediments and lunar soil, scientists have found radioactive iron-60, a rare element forged only in supernova. It decays quickly on cosmic timescales, surviving only a few million years. Its presence shows that material from nearby stellar deaths brushed past Earth not long ago, precisely when the solar system is thought to have drifted into this bubble. You live in a region shaped by loss, yet filled with quiet beauty, a place where endings became beginnings. And as you breathe slowly now, you carry within you the dust of stars that vanished long before the first human looked up. Let your body settle. Let your thoughts fall into stillness. You're drifting through a space shaped by ancient light, and it holds you gently as you rest. NASA astrophysicist Neil Geralds once reflected that dying stars are both creators and erasers. They scatter the building blocks of life, yet their power can wipe it away in a heartbeat. That gentle tension, that balance between birth and loss, shapes the place you drift through now. You are safe in this moment, far from any star on the brink of collapse. Yet all around you, the quiet traces of ancient explosions still shimmer, like smoke that never fully faded. If the local hot bubble could be seen with your eyes, the night sky would be wrapped in a faint violet dome stretching across constellations past Orion, through Taurus, beyond the Pleiades. Every familiar star would appear strung along its rim, tracing the edges where new suns are still forming. Inside this enormous hollow, even the bubble carved out by the sun's own solar wind grows larger than usual. With so little dense gas pressing against it, the heliosphere expands more freely, swelling gently in the surrounding void. Some scientists believe this environment even shapes the way cosmic rays enter our solar system, subtly changing the particles that reach Earth, so the space you move through is not empty at all. It is alive with the quiet remnants of stellar endings, the very forces that allowed life to begin. Carl Sagan once murmured a truth that feels especially intimate here. You are made of star stuff, but perhaps it is even more literal than you imagined. You are floating inside the lingering breath of those stars, living within the structure their final moments carved. This is not just a tale of the past. It is the very environment that cradles every sunrise you have ever seen. When astronomers map the Milky Way, They now view the local hot bubble as a single cell in a vast honeycomb, a network of cavities sculpted by cycles of stellar death and rebirth. Our small corner of the galaxy may be one of the most carefully charted, yet one of the most quietly mysterious. So, are you truly living in the shadow of 15 dying stars? Every observation suggests yes. Even the iron in your blood once glowed inside a supernova that may have helped hollow out this very space. The universe does not hide its history. It lets it drift around you softly, like dust settling after an ancient storm. And one question lingers at the edge of this calm darkness. If this bubble was born from destruction, could it also be one of the reasons you exist? Part 2. Did supernova write the opening chapter of our story? Every grain beneath your feet carries a memory older than Earth. In the quiet sediments of the seafloor and in the fine dust of the moon, scientists have found delicate traces of radioactive elements that could only have come from stars that died millions of years ago. These isotopes, iron-60, do not last long on cosmic timescales. With a half-life of just a few million years, any sample found today must have arrived recently, delivered to Earth by the drifting ashes of a nearby supernova. The first strong evidence appeared in 1999, when physicist Klaus Nie and his team discovered iron-60 embedded deep within Pacific crust. The layers of rock revealed a clear time stamp, about 2.6 million years ago. A plume of stellar dust brushed across Earth, the same era when the solar system is believed to have entered the local hot bubble described before. Since then, the pattern has been confirmed again and again, in Antarctic snow and in lunar samples brought home by Apollo astronauts. Nothing on Earth could have produced these isotopes. They could only have been forged in the final moments of a star's collapse. Why does this matter? Because each tiny speck of that dust carries the chemistry of death, and perhaps the chemistry that allowed life to emerge. When a massive star collapses, its inner layers are squeezed to unimaginable densities. Temperatures surge to billions of degrees. In those final breaths, elements heavier than iron are fused, and waves of energy hurl new atoms into space at incredible speeds. Nickel-56, cobalt, and ampulla. Iron-60. The raw ingredients of worlds are scattered like seeds across the galaxy. These aren't just numbers. They are the heartbeat of the universe teaching itself to begin again. Supernova are the most efficient forges of heavy elements known. Without them, there would be no oxygen for your lungs, no calcium in bones, no gold, no planets at all. NASA astrophysicist Brian Fields once said, "We owe our existence to these immense stellar endings." A poetic statement, yet grounded entirely in science. Evidence suggests supernova not only created the elements that make life possible, they may have triggered the birth of the solar system itself. Picture the cloud that existed 4.6 billion years ago. Cold, quiet, drifting gently in space. Then, a nearby star exploded. Its shockwave rippled outward, squeezing that cloud into collapse. Within a short cosmic moment, a new star ignited, your sun. And around it, a swirling disk began to gather the material that would become planets, moons, oceans, and eventually, scientists have found proof of this ancient nudge inside meteorites that fall to Earth. Tiny minerals inside them contain aluminum-26, another short-lived isotope formed only in supernova explosions. Its presence across many meteorite samples suggests the entire newborn solar system was dusted with fresh stellar debris just as it formed. Simulations show that a supernova about 15 to 20 light years away would have been close enough to compress the solar nebula, yet gentle enough not to destroy it. A precise push, dust becoming destiny. Imagine that. A dying star's final breath sweeps across the galaxy and softly touches a silent cloud. The cloud that will soon become home. The carbon you breathe. The iron in your blood. The phosphorus threaded through. Your DNA, all of it, was first built inside stars that died before the sun existed. ESA astronomer Detlev Koshny once said, "We are the ashes of ancient stars arranged into something that can look back and wonder." And the Iron 60 found on Earth tells a newer chapter. Not about your distant beginnings billions of years ago, but about a recent encounter with a supernova that may have influenced the world you live in now. Had it been too close, life might never have survived. Had it been too distant, Earth might never have felt its touch. Instead, it seems to have passed at just the right distance, around 100 light years away, far enough to spare life, close enough to leave a mark. Some researchers even suggest bursts of cosmic rays from such nearby events might have influenced climate patterns, subtly shaping extinctions and new beginnings. A universe gently adjusting the dials of habitability. And even now, the traces continue to drift in. NASA's IBEX mission has detected particles of interstellar dust flowing into the solar system. A quiet reminder that the remains of ancient stars still brush past you. Their atoms move across space like whispers. Small messages carried over. Light years of silence. There is a truth astronomers love for its elegance. The same short-lived isotopes that mark stellar death also allow us to measure time itself. By studying the decay of Iron 60 and Aluminum 26, scientists can date the birth of the solar system with astonishing precision, down to a narrow window in cosmic history. And here you are, breathing softly inside that timeline, surrounded by the traces of stars that rose, burned, fell, and made room for you. In cosmic terms, it's like knowing not only the birthday of our world, but the exact hour it began. The precision feels impossible, and yet the story it reveals is deeply personal. We can trace the moment when the ashes of vanished stars became the ground beneath us. A writer once said that to bake an apple pie from scratch, you must first invent the universe. Tonight, the idea stretches further. To create you, the universe first had to break itself apart. It's astonishing to imagine that the most violent events in existence are responsible for the most delicate forms of life. But this isn't metaphor. It's simply how matter chooses to change. Every star that ends in brilliance sends a chemical message across the galaxy. And the stars that follow read it, fuse it, spin it, and scatter it again. This is cosmic continuity, not through survival, but through transformation. So when scientists study Iron 60 at the bottom of the sea or in dust gathered on the moon, they aren't examining debris. They're reading the earliest chapters of our story. Each atom is a letter. Each isotope a memory kept safe for millions of years. And the more we uncover, the clearer it becomes. Earth's history isn't written only in rocks and tectonic plates, but in the remains of supernova. It is stellar archaeology, a field where exploding stars become historians. Researchers continue modeling how these isotopes drift through the void, tracing their paths back to places like the Scorpius-Centaurus Association, the region where many of those ancient detonations likely occurred. The timelines line up beautifully. Those supernovae happened just when Earth's earliest ancestors were appearing in the fossil record. Coincidence or cosmic rhythm? The science remains the same, but the wonder deepens. By every measure, supernova helped write the story of our existence. They carved the environment the solar system formed within and shaped the chemistry that life still depends on. As we float through the quiet interior of their long-faded blast waves, another thought rises. Light as dust in starlight, could these stellar ghosts still be shaping the birth of new worlds somewhere beyond our sight? Part 3. What created the giant bubble around us? It shouldn't exist, yet it does. Surrounding our solar system is an enormous, nearly spherical cavity, filled with million-degree plasma and wrapped in delicate threads of dust and gas. It spans nearly 1,000 light-years and glows softly in X-rays, a lingering echo of explosions from long before anyone looked at the sky. Astronomers call it the local bubble, and thanks to data from NASA's DXL mission and the European Gaia observatory, we now know that every young star near the Sun lies along its surface. It's as if the deaths of old stars hollowed out a space for new ones to be born. This bubble is not just a scar, it's a cradle built from fire. To understand its past, scientists use DXL to map the faint X-ray glow that fills our region of space. These rays come from gas heated to over 1,000,000 Kelvin, the residue of shock waves from long-gone supernova. Meanwhile, Gaia traces the exact positions and movements of more than 1 billion stars, creating the most detailed 3D map of our cosmic neighborhood. When these data sets were combined, a picture emerged. Young stars, only a few million years old, line up along the bubbles in a wall. Regions like Perseus, Taurus, Ophiuchus, and Chameleon are not scattered randomly. They form a vast interconnected shell of new stars, tracing the bubble's edge. One astrophysicist calculated that around 15 supernovae erupted over millions of years to carve the cavity we inhabit today. Each explosion pushed the bubble outward, compressed gas along its boundary, and sparked new stars to life. It's one of the most beautiful paradoxes in astrophysics: destruction feeding creation. Imagine one star reaching the end. Its shockwave sweeps through surrounding space, gathering gas into a dense rind. As that gas cools, gravity takes hold once again, forming the next generation of stars. Those stars will one day explode too, pushing the bubble even farther. When astronomers reversed the motions of these young stars using Gaia's measurements, they all seem to converge toward the same region, the center of the local bubble, revealing their shared birthplace. This isn't theory, it's a reconstruction of our region's history. Another scientist put it simply: the local bubble isn't frozen. It's still growing, still expanding, still shaping the sky. It moves outward at roughly 6.5 kilometers per second, the long echo of supernova that detonated millions of years ago. The gas inside reaches temperatures near 1,000,000 Kelvin, far hotter than the surfaces of many stars, but it is so thin that it produces no visible light. Only satellites can detect its faint X-ray whisper. Along its edges, however, the story gains texture. Dense molecular clouds cling to the boundary nurseries for newborn stars. Every major star-forming region within 500 light-years lies along this rim. The alignment is too perfect to be coincidence. Our region of space was sculpted by supernova, a self-regulating cycle where stars explode, create cavities, and trigger the next generation. NASA's visualizations built from Gaia and 3D dust mapping revealed the bubble in vivid structure. Bright clusters like Upper Scorpius and Upper Centaurus lupus sit along its walls, young, vibrant, and clearly born from the shock waves of dying stars. The bubble spans nearly 600 light-years across, and the Sun now sits near its center, a place once filled with overlapping shock waves. It's like living in the quiet center of an ancient storm whose ripples have frozen in place. Scientists believe this bubble is just one cell in a massive network. Other cavities, the lupus, superbubble, the gum nebula, connect through narrow channels, forming a galactic honeycomb stretching across thousands of light-years. Each bubble is a fossil of past explosions, still shaping the galaxy's evolution. But one of the most surprising discoveries is this: our Sun didn't form here. It drifted into the bubble about 5 million years ago, gliding through the hot, thin gas without disturbance. It now rests almost perfectly at the bubble's center, a cosmic coincidence of astonishing proportions. We are floating in a moment of serenity carved by the deaths of stars. Every sunrise unfolds inside the memory of those 15 ancient explosions. The space between the stars isn't empty. It carries the warmth of a violence long faded. This background glow, once thought to be nothing more than cosmic noise, is actually a living storybook of stellar evolution, the most vivid proof that in the universe, nothing is wasted. And as we continue to map these structures, a new question begins to rise. If this bubble is only one chamber in a chain of ancient scars, what waits beyond it in the next void, the next remnant of time? Part 4. Are we drifting through the ashes of dead suns? 5 million years ago, the Sun wandered into a region it didn't create. It wasn't born here, it simply drifted in. Now it floats in the center of a vast cavity of million-degree plasma, the local hot bubble, an enormous pocket of heated gas and ultra-thin dust. It's a place where matter is so sparse that entire rooms could hold not a single atom. And still, the bubble glows in soft X-ray, a ghostly reminder of supernova that exploded long before human beings evolved. NASA's DXL mission and Gaia's precise measurements revealed a remarkable truth. Our solar system is positioned at nearly the exact center of this cavity, a place shaped by overlapping shock waves from around 15 massive stars. Their combined force carved out a hollow shell of thin, hot plasma still expanding today. One scientist put it plainly: we're passing through the remains of stellar death. That phrase, the quiet remains of stellar death, feels almost too small for what surrounds us. You're moving through a place shaped by stars that lived fast, burned bright, and then scattered their final breath across the galaxy. The space around you is not solid or permanent. It's a passing shape, a temporary wound in the interstellar medium, slowly cooling across millions of years. And yet, it holds its form because of a fragile balance, the heat inside pressing outward, and the colder gas outside leaning inward. This balance forms a shell of dust and molecular clouds, a soft boundary between creation and what came before. Within it sits a hollow, self-sustaining sphere, one of the most stable, empty spaces in our corner of the galaxy. Even as the Sun drifts through it at nearly 20 kilometers per second, the interior pressure stays steady. shaping the heliosphere and letting it stretch farther than usual, nearly 100 astronomical units before it meets interstellar space. Every spacecraft that has crossed this frontier, Voyager 1, Voyager 2, New Horizons, carries the traces of that boundary. Their instruments felt the subtle shift as they stepped from the solar wind into the quiet ocean beyond. And when Voyager 2 measured plasma just outside the heliopause, the data revealed something stunning. Even beyond the sun's reach, the space around us remains almost unimaginably thin. Not dense clouds, not heavy gas, but the faint residue of ancient supernova, still drifting through the region. This isn't just poetic language. Dust from those explosions continues to settle onto Earth even now. In Antarctic snow and deep-sea sediments, scientists have found iron-60 and manganese-53, short-lived isotopes that only nearby supernova can produce. The most recent wave of stellar debris swept through here 2 to 3 million years ago, just as early human ancestors were taking shape. In those ancient skies, the faint light of those explosions still lingered, now visible only to sensitive X-ray telescopes. The universe looked calm, but its history was written in that soft afterglow. Despite all this, the sun remains untouched. The bubble that surrounds you has cooled enough that its violent beginnings have softened into equilibrium. The shock waves have faded. What remains is warm plasma held in place by magnetic fields and the faint breath of nearby stars. One scientist once said that space is alive with the traces of everything that's ever happened, and this bubble holds that truth more clearly than almost anywhere else. It even shapes how cosmic rays reach us. Because the bubble is so thin, high-energy particles travel through it more easily. And scientists wonder whether these changes may subtly affect Earth's climate or the slow rhythm of genetic mutation over vast periods of time. Nothing here is isolated. You are part of a vast exchange, matter and energy flowing across millions of years. Life and death intertwined on a galactic scale. Then came an unexpected discovery. The bubble is still growing. Gaia's precise star maps reveal that its boundary continues to move outward at about 6 kilometers per second. At the far edges, clouds are being compressed, and new stars are forming, lit by the pressure of explosions that happened long before humans existed. Neighboring bubbles sometimes brush against ours, shaping one another gently over the ages. Seen this way, the Milky Way resembles a network of connected cells, each one formed from the fading light of ancient stars. The eROSITA mission mapped these cavities as if revealing the architecture of a living organism, tunnels, shells, and branching corridors that make up a galactic lung. And here you are, floating inside one of its chambers to feel its size. Imagine traveling outward at Voyager's speed, 17 kilometers per second. Even then, crossing the bubble would take more than 100,000 years. And beyond its boundary lies another bubble and another, each one holding the memory of stars long gone. So yes, you are drifting through the ashes of dead suns. The sun's warm light falls across Earth, while the faint heat of ancient supernova still whispers through the space around us. One thinker once said, "We are made of star stuff." Now we know we are also moving through it. Every photon that reaches Earth travels through this million-degree haze, invisible to our eyes, yet mapped with extraordinary detail. It is a border between what once lived and what now grows. If the sun wandered into this chamber by chance, it's natural to wonder what lies farther ahead, perhaps a space even older, still glowing in ways we haven't yet learned to see. Part 5. What if the vastness around you isn't empty at all? What if, hidden beneath the softest X-ray glow, the galaxy contains tunnels, immense corridors of gas and magnetic fields linking one stellar region to another? It sounds like the outline of a dream, but recent observations suggest it may be real. The bubble surrounding the solar system is not solitary. It connects through immense channels to other cavities, enormous structures like the Gum Nebula and Lupi, each carved by ancient supernovae. Together, they form a network of hollow spaces and glowing filaments stretching across the Milky Way. eROSITA's all-sky X-ray map revealed these structures with unprecedented clarity. Low-density, plasma-bridging, star-forming regions like threads within a living web. One astrophysicist described it as a cosmic sponge, a collection of interconnected voids shaped by the explosions of generations of stars. Imagine blowing soap, bubbles in a dark room. Each bubble expands until it touches another, forming delicate tunnels at the places where their walls meet. The galaxy behaves the same way. Over millions of years, exploding stars carve out cavities that eventually intersect, forming bridges of hot plasma hundreds of light years long. Our solar system rests inside one of these intersections. To one side lies Lupi, filled with young stars and their remnants. To another, the Gum Nebula, a sprawling structure of expanding shells and magnetic threads. These channels are not silent emptiness. They're active pathways where particles, dust, and magnetic fields flow freely, measurements of how polarized light twists as it passes through. Magnetic fields show something remarkable. These tunnels align with large-scale magnetic structures sweeping across the entire sky. One astronomer proposed that what we see may actually be a vast magnetic corridor surrounding the solar system, a structure that would appear exactly as the glowing filaments in our radio maps. It means you might already be inside one of these tunnels, drifting through its invisible currents. The idea fits the data. The boundaries of the local bubble mark places where multiple cavities overlap, forming the perfect conditions for long channels of ionized gas. They act like galactic pipelines, carrying matter and energy across great distances, helping regulate temperature and perhaps guiding gas toward regions where new stars can form at nearly 1,000,000 degrees. This gas glows in X-rays, but remains too thin for the human eye to detect. And yet, eROSITA's sensitive detectors outline these networks with astonishing detail: arcs, bridges, and filaments stretching across the sky, rendered in 3 dimensions. They show that the solar system sits at a crossroads of multiple tunnels, a position that may influence the flow of cosmic rays, drifting dust, and even the long-term behavior of Earth's magnetic environment.